All right, let's try this again. A ball is thrown directly downward with an initial speed of 8 meters per second from a height of 30 meters. After what time interval does the ball strike the ground? So the height here is going to be 30 meters. But I like to put the variables in there. So, all right, let's solve this. The ball is thrown directly downward with an initial speed of 8 meters per second. So that's the velocity. 8 meters per second downward. And at height, which I'm going to call h, being 30 meters. So the way you solve this, folks, is let's conceptualize this for a bit. So this is going to be the t-axis, and this is going to be the y-axis. I am behind on the edibles at the moment, but that's okay. So a ball is going to be thrown straight downward. So that means that this parabola is going to have this type of shape. So it's going to have some initial velocity, whatever that, or which is negative 8 meters. And that motion graph is going to be y equals the y, depending on what x is. It's going to be some initial y, h, 30 meters, minus v naught t, because I put v naught here as a positive value, so I put a negative to compensate. Once you got your equation, you have this formula. So you use the quadratic equation, so 8 meters per second plus or minus the square root. We're going to use the plus portion because we're going to 64 meters square second square. So that's going to be a minus, and it's going to be a plus 9.8. What did I put? 0.8 times 2. Oh, I guess I'll put a 60 meter. I kind of screwed it up here, but that's okay. All over 2 times 30 meters. So put this in the calculator, folks. All right, folks, there we go. So I'm not sure why I'm not getting the right answer here. I do know the answer. I'm not sure where I went wrong here. H minus VT minus 4.9 T square. It does get us a 0. Anyway, the answer is going to be T being 1.79, I think. 1.79 seconds. I hope I didn't screw it up somewhere, but that's all right. All right, folks, enjoy.